So hey guys, welcome back to another lecture. So previous lecture we have discussed the quartiles. In that we have discussed the percentiles, quartiles, and deciles. So today we're going to discuss something known as the variance. So what do you mean by this variance? So first I just want you to research about what is variance. So after this lecture I just want you to research what is variance and all. So in a brief, the variance is just a measure of how much data points from the differ from the mean. So mean is the middle, right? So we have a data points, like we have a data set here, and this is a mean here, this is a mean here. So we have one. So if they are the data points here, and the variance tell like from how much these data points differ from the mean. If we have 1 meter here, and this have 2 meters here, and this have 3 meters here, like this. So this is how far the data sets from the mean, which is average value, right? So this is how far the set of the data are spread out from the average value. So the more variance, the more data is scattered and spread out from the mean. If there is a more, means like there is a more variance, means the data points which are long distance from the mean here. So if the data points are here, so these are near to the mean, and these are the far to the mean. This is the mean here, right? So these are the far from the mean, and these are the near from the mean. So the more variance means they are far and they scattered. If we draw the graph here, so the graph look like this, right? So they are more scattered and spread out from the mean here, right? So we will take how we gonna take this. So if we have how we gonna take that variance, right? So we just simply comparing with the mean, right? So we just simply take out the mean first. We just simply take out the mean, which is x bar here. So we just simply, after taking this, the mean is, so we just simply add these. By taking the mean, we just simply add this, and we're gonna simply multiply what are the number of data points, and we will get our output as our mean as a 5.6 here. And how we gonna find the variance here? So the variance means like this, how far the data points differ from the mean here, which is 5.6. Means like we have to find the distance from the data point 1 to this mean. So means like we are subtracting this from this, and then we simply doing the n minus 1, which is the number of observations minus 1. So why we are using -1, we're going to discuss further lectures. So like as of now, just means like I just wanted to give example. I will explain for the lecture, but you can research on your own, like why we are using -1 not +1 here. Okay, so we just simply subtract every data point from the mean here. So we are subtracting the 2 here, and we are subtracting this from the mean here, and we are doing the same with all the data points 9, 10 here, etc. And then we're simply doing the n-1 here, and this is a variance. So I just want you to multiply these, and I just want you to calculate these and tell the answer here. So how far the data from the mean? This is a variance. Okay, so like how we gonna find the spread from the data, right? So how we gonna find that spread from the data? So we have seen the variance, right? We have seen the variance. If we square that up, this leads to a new term, which is a standard deviation. So like what is standard deviation? So we're going to look in just a few minutes. Okay, so there are two kind of variance, which is a sample variance, and we have a population variance. We have discussed this sample mean and this population mean. So same goes with these. In sample mean, we have a n-1. We have taken this here, right? So we have taken this here, which is n-1 here, which we take n-1. We just simply data points minus mean. We just simply square this. We just simply square that value. So why we are squaring means like if we get our negative values like this, if we square this up, then the negative will cancel out, right? So I hope you understand this. So this is a sample variance here. So like this, we just simply add a summation rule here, because we are adding these all the variances. So we just simply data points minus mean square by n-1. So x is a mean, x1 are the values of the data, which are the data points here, and the n is the total number of observations. Same goes with the population variance also. So like in a population variation, we use this sigma square. So this is a sigma. Okay, so like how we gonna mean 1 to n, which is, so we here we are using the population, right? So we may not know like how much the population, right? So we just simply use n here in the population mean, which is mu, and we just simply track the mean here from the, and then from that, and then we simply square that up, and then we simply divide this with a capital N, the capital N used for the population. Okay, so I hope you understand this. If you don't understand, please re-watch that video. Okay, so after that we have a concept of exception. So what is this concept of exception? So it helps to find the variance of the probability distribution. So it finds the variance of the probability if you have a probability distribution, and it finds the variance of that probability distribution. So like if we have a distribution of -100 and 100, so what is this probability of exception means? Like, so like if we have a 50%, for x, which is equal to the -100, and we have a 50% over here, which is x is equal to the +100 here. So if probability of this also means like they are two, right? They are two random variables here, which is -100 and 100, means like there is a 50-50 chance here. There is a 50-50 chance here. So like 50% chance for -100 and 50% chance for 100. If 0, then otherwise, if 0 otherwise, means like if they both not, then it is 0. So we have taken the x value, right? So after that we are also taking the y value, which is 0 here. So the probability of this, which is y, is equal to, if it is 1, means like if it is true, then for y is equal to 0, otherwise it is 0, right? So I hope you understand this. So like it is a kind of a complex thing, but it easy, like if you put your mind here. So we are taking 1, means like if it is yes, it is yes, then the y is equal to 0, otherwise it is 0. Here these two are, if s are, if s, then it will give the -100 or 100, otherwise it will give 0, right? So how we gonna this expectation, like how we gonna find it? Okay, so we have a summation over here, and then we simply multiply these two. These two. So like we are multiplying with these, and we are multiplying with that probability, and we are multiplying with these, and we're gonna multiply with that probability. We have multiplied with this probability, and we're going to simply get 0, because -100 plus 100 will cancel, and we're going to get out 0. And if we same expectation of y, which is also equal to the summation of g of x minus p of x, which is equal to the g of x, which is this. G of x means the probability is 0. So like we just simply 1 into 0, which is 0, means like the expectation of e of x and the e of y is equal to 0. Then we can say that this is accepted, expectation is accepted, right? So this is a concept of expectation. So like note, there's a note here, like both random variables have same mean value, right? So then their distribution completely different. So sometimes there is a, so their distributions like this, but they may have the same mean value here. The mean value might be same. Sometimes we have problems like this, like we have a same mean value, but their distribution is completely different. Sometimes we going to face in our problem sets, don't worry. Okay, so means like if this is a 0 here, and we are getting these also far away from the mean, so here the mean is 0. So like this is a distribution here, and this is a -100, and this is a 100 here, this is a 0 here, this is a mean is 0, this is a mean is 0, and these are the far away from the mean, so like in a distribution here, so this describes the variance. Like, so we have taken this -100 and 100 example, right? So these are the far away from the means. So what is variance? It tells how far the data points from the mean, right? So I hope you have a basic intuition. Okay, so after that we have seen all these, like here the variance of y is quite small, since the distribution is concentrated as single value. See, the y is quite small, which is almost 0, right? So like this is concentrated on a single value. So where the value x is large, we have seen this x is equal to, x is large, it is 100 and -100. these are the far away from the mean. These are the far away from the mean. So like we have a formula out there here, which is E into x minus mu. We have seen this is a variance formula, right? The data points minus mu, which is a population formula. Mu is a mean here, and then this is equal to the summation of, we just simply multiplying with this the probability of that. We just simply multiplying with the probability of that. So if you multiply these two, and we're gonna get this minus 200 square by 2 minus 1, right? We have n minus 1, right? I hope you understand that formula. I hope you remember that formula. And we have n minus 1, which is 2 here. The data points are 2, and then we simply 2 minus 1, and then we're going to get as a 40,000 here. So the variance is 40,000. Means like what if we don't square the expected value? What happens if we don't square the expected value? So like if we don't square that value, if you don't square that value, we have seen, right? We have seen here, it is equal to 0. We have seen, right? It is equal to 0 here, right? So like if you don't square that value, then this gonna be like e of x minus e of mu x, which is equal to the mu of x minus mu of x, and this is equal to the 0. We have seen this, right? So we square that value. If you don't square them, the difference between the xn and the mean is the results 0. We have seen in our previous lectures, right? So we are taking the variance of these two values, x and y. Here we are taking the x, and we have a formula out there, and then we simply do the calculations, and we're going to get the variance of x is equal to 10,000, and the variance of y, which is equal to the 0. So you can see the variance of y is a way large than the variance of y, right? So let's say we have a data set which states the data set of a watermelon in meters, okay, but the variance of x has a different unit. So this has a different unit, variance of x. So say x is in meters, then the variance of x will be the meter square, right? I hope you understand these meters, and these. I hope you have a familiarity with these meters and meter scales. What are these? I hope you know these. If not, then please research about that and then come back. Otherwise, it will be hard for you. Okay. So like the unit of x here is not equal to the variance of x here. Here the meters. Hey, we have a meter square here. So this is an issue here. So how we gonna solve that issue? So here we take the square root of that variance here. Here we take the square root of that variance. So this leads to the another term, another measure. This leads to the another measure which is called as a standard deviation. This is called as, we simply square root that variance of x, which is standard deviation. So like what do you mean by this standard deviation? We simply take the square root of that value, which is variance of x, which is 100, the square root of y, which is 0, and then we're going to get 0. And after, there is a computational formula for the variance. We have seen this, right? So I just want you to explore it. So how we find this formula, how we get this formula? So I just want you to give a hint, like we have a minus b whole square is equal to a square plus b square minus 2ab. So this is a hint, and I just want you to explore on your own, okay? So I means like I'm not a person, I didn't like the spoon feeding, okay? So you have to done your part, okay? So if you research, then it's a kind of assignment, okay? So do it by heart, okay? So the variance of x, which is ex square here, and we have this. So this is a, we have seen this, right? So the summation over here, and we have a x over here, and then we simply have a probability of that x, and this is a mu square x, which is a mean square x. This is equal to the summation of this probability of that x is mu square, and then it will become like mu square, right? The mu square of the population mean. This is the mean square of that population mean. So like if, for example, if we roll a die and let x be the value of a number and find the expected value, right? So how we gonna find that expected value? How we gonna find the variance of that? And how we gonna find the standard deviation? So this is a very good practical example. How we gonna find that? So like this is a random variable, and we have rolled a die here, and we're going to get output as whatever it may have a 1 2 3 4 5. These are the outputs, right? So these are the events, like it may give 1 or 2 or 3 or 4 or 5 or 6. So it may give these values, and the probability of that constant, which is equal to 1 by 6 here. We have seen this example in a previous lecture, so if you watch those, and it will be easy for you, right? So if not, then please watch that. Okay, so we're going to take that every probability of that, and we're going to get as a 3.5 here, right? So as of now, just for computation purpose, it will be easy for you. Okay, so and we just simply squaring that value, right? Like if here we have 1 here, and we simply taking the 2 square here, 2 square which is 4, and we are taking the 6 square here, which is 36, and we're going to find that here. We're going to find that. So after that, we have a good formula for the variance, right? Direct formula for the variance, and then we simply implement these here. So ex square, which is, we have find this, right? It is 91 by 6, and we have a, why this 7 by 2 square, you may get like, so this is a e of x square, and then we simply squaring that value. We are simply squaring that value, which is 7 by 2 whole square. This is equal to the 7 sevens of 49, and this is by the 4, and then we see, if we do calculations here, and we're going to get output as a 2.92, and this is the variance. After variance, how we going to find the standard deviation? We simply square root of that variance. And we're going to simply find the standard deviation here. So the standard deviation is simply square root of that variance, and the square root of 2.92, which is approximately equal to the 1.71 here. So this is a variance, and this is a variance, and this is a standard deviation, right? So I just want you to try new examples, so it will give a practical hands-on experience, and you will remember if you practice more. Okay, so I hope you love this lecture. So in our next lecture, we're going to start with the covariance. So what are the covariance and etc. We have discussed the variance, right? We have discussed the variance, and what is the covariance, and all we're going to discuss in our next lectures. So until then, bye bye, see you in the next lecture. I hope you love this lecture. If yes, then please subscribe and share with your friends.